Hi folks, welcome to the Virtual Estimating and Repair Planning Workshop from ATI. We're going to call this VERSW just for future reference, but what we're going to go through today is your pre-class workbook. The reason we do this, we have an objective, and the pre-work packet is designed to ensure that the participants that will be attending this workshop will have a basic knowledge of damageability, repairability concepts. This includes being exposed to the typical nomenclature used in estimating and repair planning processes. This allows for a knowledge gain throughout the workshop segments. These segments will include visual references, including PowerPoint slides, the audio presentations, and workbook text. Also included will be self-check questions, which will be completed during the self-guided workshop process. So during the course of the workshop, participants will be provided with information following a specific flow so that each segment builds on the previously provided segment content. Included in each segment are a series of knowledge check questions, as we said, which will validate the participant's level of understanding of the materials. It's important to follow this process in its entirety, as it is structured so that when the participant conducts their repair planning or estimating processes, any communication between the estimator, and we're going to say estimator / RP or repair planner, and when they have the communication with the production team, that there will be consistency in that presentation. This consistency helps bring accuracy and improve production efficiency to the repair processes. During each of the segments, participants should take notes, and in the event there is a need for further clarification, we can answer those questions at a later time. Before beginning the workshop, there are two definitions that we must address. One is, what is an estimate? And an estimate is an approximate calculation or judgment of value, number, quantity, or extent of a rough calculation or judging of value, number, quantity. What that means is the insurance companies use these to close a coverage. They get an approximate guess, if you will, for what the damage will cost to repair. They pull their money out of investments. That money is then used to pay for the claim. Then it's supplemented if additional work is required. Now that's different from a repair plan. The repair plan is the process by which the restoration of a broken, damaged, or failed device or equipment part or property to an acceptable operating or usable condition or state. What does that mean? It means we've got to put the vehicle back to pre-loss condition so that the function of all of the mechanical systems, the body systems, and the safety systems are in the same condition they were prior to the loss. So that is a distinct difference between an estimate and a repair plan. As we go through this training and the further training that you'll get with ATI, we are going to build on that so that as you prepare for negotiations or you prepare for discussions, you will have a thorough understanding of what is required within the repair plan so that the vehicle can be reconstructed so that it has the same characteristics again as it did prior to the loss. So the RP, the repair planner, is going to be held to a much higher standard, and their expertise and accuracy will be scrutinized in much more detail because they are expected to do a meticulous disassembly of the vehicle and identify all the required parts and operations before beginning work on the vehicle. So we're going to talk about general terms and nomenclature, and the first term that we're going to cover is inertia. This is a law of motion, and it's to be considered in every crash scenario. And why? If I have a brick wall, let's say, and that vehicle hits the brick wall, as the front of the vehicle stops, the balance of the vehicle tries to continue to move forward. So what that does is it causes the internal components to try and crush to meet the front where it stopped. So inertia basically is a change in the state of the vehicle. And this is what causes something that's called indirect damage, which we're going to talk about in detail. So the first term, inertia, we will have a very detailed video from the Insurance Institute for Highway Safety, which goes through various crash tests so that it illustrates how the parts within the vehicle actually move. Because when the vehicle stops, and I get a bumper system stops, the motor, transmission, which generally are transverse, will continue to move forward. Everything that's connected to them will also try to move forward. So we have to look at things like the tearing of mounting locations and things where those things bolt. So inertia is a very important part of this process. So what we're going to do as we go through this is we're going to look at what are the visual indicators on the vehicle that we will be able to actually see. Some will have to measure that show us that the inertia or that travel has occurred through the vehicle. So let's start with the structure itself. Let's talk about the unibody. The unibody is, it means that all the components that make up the structure of the vehicle are welded together. You've got various bolt-on parts that go on, but typically if those parts are removed from the vehicle, it wouldn't have a whole lot to do with the crashworthiness of the vehicle. The structure of the vehicle itself is made up of all those components being welded together. So that's why it's considered or they call it in Europe, it's considered a monocoque body style, where the chassis and the body are all one. This is really important because as we look at those bolt-on parts, the gap and flush, which we're going to talk about more in detail, the gap and flush are something that are a visual indicator that you will use to identify how far the damage has traveled through the vehicle. The second thing that we do as we're looking, visual indicators are always probably our most important aspect of doing the inspection of the vehicles, because we don't measure it initially. So the first thing we're going to do is, what are the things that I can see that will tell me that there's been movement in the vehicle? But the next thing that's important to us and is critical in, again, reconstructing the vehicle is structural measuring. This is done, there's all different kinds of equipment and measuring devices that can be used. Anything from a basic tram gauge, which is a mechanical system that basically it's a tube, depending on how much money you want to spend on them. The tube, as you pull it apart, will give you in metrics what the measurements are in the center, or some you just take a measuring tape and measure end to end, and that gives you your measurement. But that would be your most basic system. What we typically see is a three-dimensional measuring system. The one that we see the most right now, and the one that you have the visual of, is the car liner system, and this is called a ferro arm. And all you do is move it to specific points on the vehicle, hit the button, and it registers what the measurements are. That goes against a diagram that's set up for that specific vehicle, and it tells us how far out of the tolerance, which we're going to talk about more, but how far out of the tolerance the measurements are. That indicates to us the time required and the method that will be required to restore the vehicle back to the pre-loss measurements. Then we have a full frame vehicle. This is typically what you see in a pickup truck. And these are, there's different names for them, but in days gone by it was called a ladder frame. It's a significantly different structure now. The old frame was just pieces of steel that were preformed, they were mild steel. Now we're using a liquid cast, if you will, and what it does is the liquid goes through a form and pushes the material out so that it forms the box. That's what we call hydroforming. Significantly different in how we repair the two. One can be done with what they used to call fish plating. I could put a continuous weld on it. I could put plates on both sides of the weld, and that was perfectly fine for doing a mild steel frame repair. Now with the hydroforming, we enter into a lower strength, high strength steel. And the hydroforming has to be repaired in a very specific way with specific cut lines used, and the frames in most cases are pre-marked so that it's got a little mark in it that you would cut down through that mark. Your replacement piece would go up to it, and you can section a new piece onto it with a very specific process. And the one thing that we will continue to talk about throughout your estimating processes is always referring back to the manufacturer's specifications for repair. And we'll go through that in detail, but we do not circumvent the system that the manufacturer has set up for repairing their vehicle. Their design engineers are very specific about how these vehicles are constructed, and they want all of the repairs to be done according to what they've tested as being what would be required for putting the vehicle back, again, to pre-loss condition. Some of these are going to seem elementary to you, but a fender, that's a pretty basic part, typically on the left or right front of the vehicle. Now in some cases, you may have a right and left rear fender, depending on the vehicle makeup. If you have a Jeep, you've got the fender flares, etc. That's going to be what we would consider a quote-unquote fender. A Volkswagen Bug has fenders front and rear. But typically there's going to be a difference between a typical car will have a fender and a quarter panel, which we'll explain next. But very simply, it's a bolt-on part, right or left. Again, we're worried about gap and flush, meaning the gap, and we'll go into detail later on in this program, but the gap will be, let's call it the up and down fitment of one part to another, and then the flush being how far away that bolt-on part would be from the existing static part, or the one that is welded in place. So that's how when we talk about gap and flush, that's what, and again, we'll go into that in further detail. But the important part about a fender is it can be plastic, it can be aluminum, it can be mild steel, or it can be high strength steel. So it's very important as you're creating your repair plan to know which of these materials that you're going to be working with, because it makes a huge difference in the amount of time that you would assess to that damage and request payment for in your repair processes. It also will tell you how you have to develop the repair process planning for that specific part. The next item we'll talk about is, and we call this two things now. It used to be called a quarter panel. Why? Because it was a quarter of the car. It was the rear quarter, it's welded in place, typically goes up what we call the sail panel or the C-pillar of the vehicle, and would be joined into the roof with a welding process. So that is a traditional quarter panel, and we do have lots of cars that still have that. But now we've moved into what's called a uniside. And a uniside will be the quarter panel attached to a lower rocker panel, which I'll explain in a minute. And then it goes into what's called a roof aperture, which means it goes above both doors, or a single door depending on 2 or 4 door, and then joins up in the A-pillar, and basically you've got the whole side of the vehicle structure in one part. That's why it's considered a uniside. As we talked about earlier, it's multiple panels that are stamped as one part versus being stamped individually. Now, you're not going to have this on all vehicles. Again, you may have a difference. I may have all these individual parts. Why does that matter? It matters because as I'm assigning time, typically what will happen is, let's say an insurance company or a third-party payer will say, I'm putting time on the uniside, and they'll give you a specific time, but I want to know, is it in the quarter panel? Is it in the rocker? Is it in the roof aperture? Is it in the B pillar? Or is it in the A pillar? Because just putting one specific time and not breaking it out into the individual component parts, what happens is we end up seeing less time put on the estimate, and that's a huge issue for the shop owner. So we have to, as estimators and repair planners, we have to be aware that this is an area that is an opportunity for us to maximize our repair plan, if you will, and our repair order, and add to the estimate itself. A couple other things that are important here as we look at these, and we're going to talk about foams and adhesives. As the new vehicles are coming along, what we're trying to do, or what the design engineers are trying to do, is lighten the vehicle. So the traditional fasteners, we would have welding processes, bolts, nuts, those things have weight. And so what they're trying to do is substitute adhesive bonding with a placement rivet and adhesive bonding versus using the traditional welding methodology. It is extremely important, and I'm going to stress this throughout every piece of training you take with ATI. You must identify from the manufacturer if they authorize the use of adhesives in their repair processes. It's very specific by vehicle whether you can or can't use it. There is some case law that's being developed right now in Texas that is a huge issue, where someone used an adhesive bonding process that neither the adhesive manufacturer nor the OEM recognized for that vehicle. And it's becoming an issue that the shop has to deal with after the fact. And it's getting to be a long process for them. Don't put yourself in that position. Make sure that as you're writing the estimate or the repair plan, make sure that you are going in and researching for that specific vehicle by VIN and by model production date. Make sure that you're getting the information that's correct for that vehicle. So let's look at the rocker panel, which would be the lowest part, if you will, of the uniside. Again, it can be separate or it can be part of that uniside structure. But the rocker panel itself, what you see is an outer closure panel. Behind that panel, you're going to have a reinforcement, and then you're going to have where the floor pan goes up. The reinforcement goes to it, and this would be the outer closure panel. A couple of things that are real important with this. These are again, typically welded. They can be adhesively bonded if the manufacturer specifies that. But the important part about this is when these are put in, we're building a closed, boxed section. When we do that, we have a heat effect zone that goes behind every place you weld. Behind it, you're going to burn through the black paint that's on there is electrodeposition primer, EDP. When we burn that away, we have to restore corrosion protection to the panel. What does that mean? Well, it's a whole process that we have to follow. It's a two-part either epoxy or a two-part etch material that we use first. It's put in with a wand. So we've got to think about calculating that whenever we're putting these closed box welded panels on. Then we have to also install a refinish process to seal it. Now, the refinish process can be two things. It can either be paint, depending on the manufacturer, and they will specify, or it can be what's called a wax-all base material, which is essentially a cavity wax. So those are the two things, but whenever we're putting on a closed box section, this is essential, because what will happen is, again, all those places where we welded, they immediately become corrosive hotspots. So any electrolysis that's going through the vehicle will go to that area because it's open, and then you have humidity, moisture that's created through condensation. All of that will start attacking that bare metal. So if we don't put that corrosion protection in, that hot spot then will turn into rust. Eventually you get rust perforation, then you have a warranty issue with the repair. And again, that goes back to, were all those things on the estimate? Number one. were they performed, and number two, and of course if they were performed, you want to make sure you're getting paid for everything, and we'll talk about that in further detail later, how the calculation is done. But again, it's really important that we address those issues on the estimate under each of those items that we're going to be required to perform those operations on, so that we make sure, listen, if for nothing else, we don't forget, because the technician has to do it and we're warranting the repair. It has to be done. Now doors, the next thing we're going to talk about, a door's a door. Well, not anymore, because what's happened is we're getting all different kinds of doors that are being constructed, and they not only have to have the strength and the intrusion beam for the safety of the passenger, etc., but they're trying to make them as light as possible. So what we're looking at now in the 2020 model year, and these will be introduced, it looks like Ford will be the first one to introduce it in large quantity production, but this will be an interior of the door, so the structure of the door itself will be composite. Then you'll have an intrusion beam that bolts into that composite part. So you'll have bolts at the top and bottom. The beam typically goes diagonally across the door, but the outer skin will be aluminum. So you'll have an adhesive bonding process that adhesively bonds the aluminum skin to the composite door structure, and they're extremely light. They're about 40% lighter than the typical door. So this is a huge move forward, and there's been, listen, this isn't new. We go back to the Lumina van in the late 90s, early 2000s. They had these composite parts, but they weighed a lot. So composites now have been able to be reduced significantly in their weight. And now it makes it to where, you know, the ability with the aluminum and the new lightweight composites together give us the same strength as steel, but at a much less weight, because if we look at, there's something called CAFE, the Corporate Average Fuel Economy Act, that was that's in place. It's been in place for a number of years. And so there's specific miles per gallon with the weight of the vehicle that and the size of the what's called the greenhouse where the passengers sit. So it gives us a weight ratio to fuel ratio that we have to meet. And as the cars, we want to put more people in the car, so we're making the greenhouse bigger, but the front of the car is getting smaller and the back of the car is getting smaller and the greenhouse is getting bigger. So we have to be very cognizant of the weight in the design phase, in the engineering of the vehicle. So they're coming up with all these new ideas on how to do that, and this will be one that you'll be dealing with. So here's my the takeaway for this is real simple. How do I test to see what kind of metal that I'm working with, if it is metal? Well, keep a magnet with you. If you put the magnet against the car and it sticks, it's either going to be high strength or mild steel. If you put the magnet against the part and it doesn't stick, it means it's a non-ferrous material. Now I have to find out what material am I working with. So again, I can go to my databases, I can go inside any of the estimating systems, and I can identify what the material is that it's constructed of. But again, this is just like when we go back to the fender or the uniside, we need to know what the composition of the material is so that we can write a proper damage assessment and assign the right time to it. Next, we'll talk a little bit about hoods. Same kind of thing here. And I want to give you some cautions on hoods because these are pretty important. A hood is a hood. A bonnet, if you're in Europe, I mean, we have lots of things that they're called, but it's typically just an engine cover. It just sits on top of the upper frame rails so that it gives us the ability to cover and gives us the look that we want for the vehicle. But there's some important things about this. Again, we have multiple applications of, it can be composite, it can be steel, and it can be aluminum. So again, big difference in how we repair. Contrary to what some folks will tell you from the insurance companies and one particular manufacturer, it does take longer to fix sheet aluminum than it does to fix sheet steel. Why? Because it's very malleable, flexible. So when you start to work on it, the dents actually start to move. You've got to be very careful about how you work on it because it's so thin and so pliable. So make sure we're assessing the right time to that part. Now here's the important thing. Back in the late 80s, you could have either an aluminum hood or a steel hood application for the same vehicle. Huge difference in the hinges that you would use. Why? Because if the hood is hit, if you don't use the right hinges, it will allow the hood to travel back into the driver's compartment through the windshield. So if you've got an aluminum hood and you have to replace the hood hinges, make sure that the hood hinges that you're purchasing are for the aluminum hood. Don't get the steel the steel hinge application. Don't put those with an aluminum hood, and vice versa. You can create some real issues for the driver's compartment if you don't address that properly. So that's real important. The other piece of this with sheet molded compound hoods, which you will see Corvettes, there's quite a few cars that have them. Underneath the hood, if you flip the hood over, you'll see there's a kind of a structure that you can see. Now, if that structure is sheet molded compound and it's broken, that hood's got to be replaced. Because the requirement on sheet molded compound is you have to do the back side of the repair and the front side of the repair. So it's a two-sided repair. If you cannot access the back side of that panel to do the repair, which essentially would mean I've got to remove all the interior bracing off of the hood, do the repair, then put it all back. It's just not cost effective. So as you go through those processes, be aware of that so that you're not backing yourself into a corner saying that you can repair the inner framing or the inner structure of the hood when it's not repairable. There's going to be crush zones. We're not going to talk about that in this program, but as we get further into the workshop, we will talk about what is a crush zone, what does it look like, what happens to it during the loss. Here we just want to identify that you have a hood and you got bracing. If that bracing is compromised, in other words, if it's bent and it gets kinked, then you'll have to replace it. And there's reasons for that because we've now compromised the structural integrity of the bracing, which if we repair it, it's still got an issue. Now if it gets hit, it'll allow it to collapse further. So got to be very careful of that as we go through these processes. Okay, the next, it's actually two items, but the deck lid, which would be, we always called it a trunk lid. And then, of course, the lift gate, which you have on your SUVs and minivans. Some things that are interesting about this. Now, the deck lid itself, the trunk lid, not a whole lot of changes in how those things have been constructed over the years. And for the most part, with the exception of some of the Japanese cars, you'll see that is becoming more and more of a high-strength skin that they're using. So it does change a little bit of the repair parameters. And that's one thing that we will talk about in future sessions is knowing what the heat requirements are for the different types of steel that you're working on, because it can significantly change how the part is repaired because the metal on a high-strength steel part, it's thinner, it's got carbon, that makes it high-strength steel. And as I heat it, I burn the carbon away, so it reduces the strength of the part. So we'll talk about, I'm not going to go into the molecular structure of the parts right now, but we will do it in other classes so that we can understand it's the same thing like with corrosion. You get the heat effect zone, which makes the part weaker, actually, even though you're repairing it. So we'll talk about that more later. But a couple of things with these, the lift gates that you'll see. We've got to be very careful now because these are another part that we're using either composites as a structure or magnesium as a structure with aluminum on the outer skin, sometimes high-strength steel on the outer skin. Why does that make a difference? Well, it's a huge difference when you're working on a part that has a magnesium frame. There are some very specific repair parameters. Actually, there's not a whole lot of repair you can do. But grinding, if you're welding, if magnesium somehow ignites, it is a white-hot fire that you cannot put out, and especially you don't put it out with water because it will cause it to explode. So what am I saying? Make sure that you're checking the manufacturer's specifications for the parts you're working on. We're starting to see magnesium used more and more. Jeep is using it in their spare tire carriers for the rear of the Wranglers. They're using it for the dash beam that goes from side to side beneath the dash where everything attaches to, and you're seeing that more and more. So, so Chrysler, Fiat, we've got Fords are using it. So just be aware. And how do we make ourselves aware? We go into all data, let's say, we research the information for that part that we're going to fix, and I kind of use this as a rule of thumb that works real well. Anytime I'm going to heat a panel, for whatever reason, whether it's welding, cutting, whatever the case might be, I want to pull the data for that part specifically so I know what the repair parameters are. That will be the thing I want to do as a repair planner is I want to make sure that I'm providing the repair information that's required for that part to the technician. So I'm gonna make a copy of that. I'll create that copy. Then I give a copy to the technician. I'll have a copy for the insurance company if they need it. I've got a copy if I'm going to have an explanation with the customer, and then I've got a copy for my file. So I'm going to make 4 sets of those. And if you want to find out more about negotiation tactics and how you present the information, in the portal there is information on how to set up a negotiation, and that's one of the things we go over is how to set up those 4 files for the entities that we would be sharing the information with. So like the hood, again, both of these parts, both the deck lid and the lift gate, they can be made out of different kinds of materials. So again, we need to make sure that we're identifying what material they are made out of. Now, roof panels, this becomes a little more interesting for you. A roof panel in its old form used to be just a part that came down, was welded to the A-pillars, which are the front pillars that go and hold the windshield in. The B-pillars, there would be a cross brace and they would weld there. Then the C-pillar or the sail panel, they would weld there. We are seeing a comeback of that type of structure now as we have the unisides, because the unisides go in and it gives us a real nice lip to make a small roof panel. So that is something that's we're seeing kind of the resurgence of that kind of construction, which is good because roof panels typically, if you have to fix them like for hail, let's say, you're typically always chasing the damage around because it's such a large flat panel and there's not a lot of adhesive holding it in place, so it's flexible. So as you go to repair them, you'll see well, we'll just call it an oil can. You'll see the damage start to move out if the technician isn't real careful about how they repair it. So, but the roof panel itself, this is another one, can be composite, can be aluminum, and it can be sheet steel. So it depends on the manufacturer, the type of car. I mean, Tesla, everything's aluminum. As you're working on some of these other newer vehicles, you're going to see a lot of vehicles that will be aluminum intensive. If you're working on an F-150, the new F-150, that is going to be a totally aluminum vehicle. In 2018, we're going to see that with some General Motors products as well. So we need to be at least knowledgeable about how we do the repairs to these panels. Now, here's the interesting thing about this. What you have to consider when you're working on a roof panel, look at the options on the vehicle. Does the vehicle have the integrated airbag system for side impacts. If it does, those have to be removed from the vehicle as you put the roof panel in, because you're going to be welding in the area where the ignition source is plus where the bag is. So you need to disconnect and isolate that system and remove it from the vehicle before the roof panel is installed. And I'm going to talk a little bit more about welding processes later, but that's important to know because I've got to take the headliner out. I've got to make sure that the both airbag systems are disconnected, isolated, and removed. And that's an important step in making sure that I put the vehicle back to pre-loss condition. Also, there is a secondary welding process. It's called silicon bronze, where I would join the panels together. That's another thing that we have to consider because it is a different type of welding than we would use in our traditional, let's say, squeeze resistance type spot welding. So these are some other areas in the roof panel that, again, we just have to be knowledgeable about the material that we're working with. Now, the rear body panel, this is an interesting one because it really ties the quarter panels or the unisides together. And that is what helps attach them to the floor pan, and it is a major component in how we align the parts in the vehicle. So, a couple of things we want to be, make sure we're aware of as we go through this process. I'm going to throw out some numbers here. These aren't going to be important to you now, but they will be when you're out in the field. About 47% of the accidents that we see, the left front of the vehicle is involved. About almost the same number, it's the right rear of the vehicle that we see involved. So this rear body panel is something that we see damaged quite often. And it is a structural component in that it ties everything together and does attach to the frame rails. So we do see where the degree of damage will dictate whether this part can be repaired or not. And again, that's done through measuring. It's attached to, again, a frame rail on either side. How far did the frame rail travel in? And then we look for things. We've got a bumper system that is directly outside of this panel. If that bumper system has been compromised and moved towards the vehicle, either front or rear, it will move in the rear of the vehicle, the rear body panel, in the front of the vehicle, depending on the depth of the impact, the core support. These are major tie pieces that hold the vehicle together. So it's important that we understand that these are closure panels, and they're going to attach to a left quarter panel, a right quarter panel, or uniside, a floor pan, and the frame rails. So again, it's a major component. We've got to make sure that this is right, because if it's not right and I attach a bunch of things to it, nothing's going to fit. So again, it's real important that we think through that process. A couple things that go with this that are important. These all have to be seam sealed. What does that mean? There is a seam that's going to run around the floor pan and then go back to the edge of this rear body panel. It's important for two reasons that this area is sealed. Number one, it's because of water intrusion. But number two, and we don't think about this very much, how about the gases that are coming out of the motor going out the exhaust? We've got air moving in the back of the vehicle. It can bring some of those gases back to the vehicle. We need all of those seams sealed so that gas can't come back inside the vehicle. The seam sealing part of this is extremely important. We're going to talk about that a lot as we go through these processes, but the seam sealing is two steps. I've got an inside and I've got an outside. Both sides have to be sealed. Insurance companies will try to say, we're just paying you X amount of dollars for seam sealer. Well, we're going to show you in later segments the formula that you use to accurately assess the cost of this material, because it's quite expensive. And at $50 plus per tube, we need to make sure that we're getting fairly compensated for the materials that we're going to use, not only for the materials, but for the time that it takes to install those materials. So we're going to cover that later. But again, the rear body panel ties the quarter panels or the unisides together with the floor pan, and it does attach to the frame rails. So a pretty integral part in the structure of the vehicle. Speaking of floor pans, this will be the next item we're going to talk about. This is a major structural component in the vehicle. Now, some folks will say, well, it's just stamped steel, etc. Well, each of those stampings is there for a reason. Any convolution, so I'm looking at a part, any convolution that I see, that is there to add rigidity to the part or strength to the part. So what happens is we typically see folks that'll do their pulls and they kind of just hammer it and make it look okay and they come. No, we can't do that. We've got to make sure that it is the same dimensions that it was previously. So we've got to make sure, and this is the consideration in the repair plan, how long will it take for me to make that part look like it did previously? And I'm not talking about putting plastic on it and sanding it down and sculpting it so it looks right. I'm talking about a hammer and a dolly, a slapping spoon, you know, anything that's required to move the structure back to its pre-loss position. So it's not only the shape, but it's the state of the metal that we've got. It's two things we're looking at here, the shape and the state. So we've got to make sure that we're adequately compensating the folks that are going to make this panel look the way it needs to, because here's the other part of this. There is a massive amount of welds that hold this thing in place. So when it's moved, if it's been moved and we've got damage to it, there's been significant movement in the vehicle in order for this panel to be damaged. So again, it's important for us. We've got to measure. We've got to understand what the panel is made of. In some cases, and this is a funny one, but in some cases we have balsa wood floor pans. And that was something that was used in the C5 Corvette. And it was impregnated with an epoxy resin. But we need to know this stuff, because if we're fixing it, you know, how do we decide how the car should be fixed? The manufacturer is going to tell us by how they constructed the vehicle and how they engineered the vehicle. So again, in sealing a floor pan, because it's the same thing we had with the rear body panel, the manufacturers will specify particular sealants to be used, and it goes with not only the sealant itself, but what is the width that we have to have for the sealant and the height for the sealant, so that when the part is put together, it makes sure that it is able to squash out and cover the distances that they want in their engineering. And again, it ensures that the sealing to keep the road debris or fumes you know, that are caused by the engine, it keeps all of those things out of the vehicle. Now let's talk about, we've named in almost every one of these parts, we've talked about original equipment manufacturer requirements. So that's the OEM, original equipment manufacturer. So what we want to do is, as we're doing any repair procedures to the vehicle, we want to make sure that we are doing them as specified by the OEM. There are other entities that are recognized, like ICAR, but ICAR is recognized because they use only the OEM specifications. So again, we need to make sure that we're checking the vehicle. We need to understand what happened to the vehicle. So when the vehicle hits, remember, it hits that brick wall, we got movement through the vehicle, I've got all kinds of mechanical components, I got people in the car, all kinds of things are happening. How do I diagnose what has occurred? So that brings up a great question. Are there things in the vehicle that can help us with the diagnostics? Absolutely. So we do the diagnostics through pre and post scanning. Okay, and I can go to OEM One Stop, I can go to the OEMs themselves, or I can go to ASA, and we will get from them what are the requirements for scanning by each manufacturer. And that manufacturer will tell you, and in almost all cases right now, the manufacturers are telling us that in any collision where parts need to be replaced, so any collision where parts need to be replaced, there must be a pre-scan so that we can properly diagnose if any of the electrical or electronic systems have been compromised in the loss. That's hugely important to us. It'll give us a couple different things here. First, it tells us things as simple as, did we have a connector that moved out and didn't go back into place? Because remember, I got parts moving all over the place, wire looms are being stretched to their max. In the middle, I may have a connector. Did the connector maybe come out and now I've got a drop in that, and now I've got an open circuit? I'm not going to know that unless I do a scan. And so these are the things we need to prepare ourselves for as we're going into the negotiation process, or we're selling our repair plan to the powers that be. Whether it's the owner, whether it's the insurance company, it doesn't matter. As the repair professional, I have to do proper diagnostics. Then we go through an intermediate scan process where I would be replacing parts. And so that's telling me only if the part has been installed correctly and the system would be functional. Then the third phase of this is the post-diagnostics that tell me, have I gone and calibrated things properly, and we're going to talk about that. Have I calibrated it properly, and now are the systems fully functional and ready for another impact, essentially is what we're looking at. And why do we do all this? Because the owner is depending on us as the repair professional to give them the car back in the same condition it was prior to the first loss. They're counting on us as the repair professional that if they have that same hit again, somebody drives into the same brick wall, that the airbags will deploy, that all the systems will do what they're supposed to do. So the post-scan validates that. And what else does it do for us as a repair facility? It really helps relieve liability, because the computer system, the onboard diagnostics of the vehicle, are telling us, telling the owner, telling the control unit that those systems will now function. So that's a real important factor in this. And in times when you have to do a negotiation, if you will, because there are some insurance companies that don't want to pay for this. It's severely reduced over the last year, but we still have issues with insurers not wanting to pay for the diagnostics. It has to be done. So you got to share that. Remember, we said make 4 copies. If I have an insurer that doesn't want to pay it and I've given them the information, I'm going to make sure that I go through all of the steps that are required for repair with the owner of the vehicle. It's their car. The shop has a responsibility or a contract of repair with the owner of the vehicle, not with the insurance company. So we have to explain to the owner that the manufacturer of their vehicle, the design engineers who designed and built their vehicle, say that this is a required step in our repair process. Your insurance company doesn't want to pay for it. We need to charge you for this. You can then take and go back to the insurance company with the charges, but it's mandatory for us to do this. And so again, this documentation, it's easily found now, so make sure that you find it, make a copy of it. My suggestion to all the shop owners is, I have a file for Ford, Chrysler, General Motors, everybody that I would work with, and as I find these documents, I put them in those folders. Then if I have this Chrysler product come in, I go to my Chrysler folder, pull it out, make a copy of it, and I can make the four copies for the 4 different files that I'm going to be working with. But it's just a way to kind of organize yourself and speed up this process, because it is becoming quite cumbersome, the amount of research we have to do per vehicle. So anything we can do to kind of speed that process up by kind of printing the documents so that we have them will help you in your be more efficient in that process. Okay, so we're going to go through, we said there was going to be some skill checks. So I'm going to go through the first skill check. And the first question that we have in that skill check is damage that is located in the area of impact. What do we call that damage? So can it be indirect damage? Can it be direct damage? Is it collateral damage? Or is it none of the above? Question 2. A body panel alignment can help identify when the vehicle structure has moved. Is that true or false? Question 3. 3-dimensional measuring is required to ensure that the structure is returned to pre-loss specification. Is that true or false? Question 4. Unibody structures are the only vehicles that a body shop would typically repair. Is that true or false? A full frame, question 5. A full frame can be made of more than one type of material. Is that true or false? Using OEM reference material is required to identify how repairs should be completed, describe in detail the steps required for the repair, identify when scanning is required, or all of the above. Next, we're going to talk about vehicle lighting. This is probably one of the most complex new advancements that we've seen, and it's only going to get worse. There are, I'll give you an example of the Audi headlights that are now available. Very expensive. It's about $3,400 per side, and they are capable of 1 billion, with a B, lighting iterations. So it can do 1 billion different things. Also works off of GPS. So if you're coming to a turn, it will start to light the turn up before you get to it. It has heat, like a FLIR, forward looking infrared, so that it can see if there's a heat element, whether it's an animal or a human, off to the side of the road, and it'll put light on that area. So this is the stuff that we're going to be dealing with, GPS type lighting. So the types of lights or lamps that you will see are going to be composite headlamps, HID headlamps, LED headlamps, and of course the traditional seal beams. Then with the tail lamps, it's along the same lines. We have composite tail lamps. Again, it's what we've seen probably since the late 90s. Then the HID, these are the ones that you see that are extremely bright tail lamps. The LEDs are the same, but it's a different kind of light than you would see from HID. It's not quite as bright to the eye, but it illuminates a lot more. Then you have a regular incandescent bulb lamp, which is your traditional twist-in type light bulb. So those are the different ones. Now, why does it make a huge difference? A couple of things I want to go over at this, because this is really important. You're going to be asked by insurance companies to use used parts. And in the case of the Audi, this is extremely important, because an Audi that's produced in the US does not use the same electronic and electrical parts as an Audi produced in Europe. There's an E mark in Europe, and then there's the DOT mark in the US. If you try to use one system with the other, and I'm going to give you an example, it can cause some significant problems in what happens to the lighting system, and I'll give you the example. There was an Audi that was being repaired in Upper New York State, and the insurance company identified a tail lamp, and it's not just the lamp, it's the lamp, the pigtail assembly, everything that goes with it, and it came from Canada. And so, I mean, it's close by. It was a supplier that was used. I don't know the mechanics of how that happened, but they identified it. It was sent to them. They plugged it in. The shop did everything they were supposed to do. Didn't realize the E mark versus the DOT mark, and it caused about $4,000 worth of electrical damage in the back of the car. So lesson learned. If you're using high-end European used parts, which we typically don't see, but if you do, that's one of the things you need to look for. And all it is, it's a very simple, it's got an E where you would see a DOT at the bottom of the tail lamp. That's where you would see the difference. But the look, they typically look identical. But that E mark and the electronics that feed will be quite a bit different. So the other thing that you have with some of the new technologies are the lighting systems are pre-coded to the car, to the VIN number, and you cannot change from one car to the other. And really that's by design by the manufacturer. So you've got to make sure that, again, someone is giving you the right information before you plug these things in and just start to use them. So the used part market, although we'll probably see an expanse of available parts because of some of the weather that we're seeing. However, we want to make sure that with the electronics especially, that the parts that we're getting are ones that have not been damaged previously, especially by water intrusion. So what are the things what do I look for? Well, if I just receive the part and I take it out of the box and I see condensation, I'm probably not going to want to use that part. Especially if there's integrated electronics that are bolted to it, because that gives me a question as to, number one, where was it stored, where did it come from, and could it have been in, let's say, a flood damaged vehicle. So just be very observant as we're being told to order parts in some cases, where those parts are coming from and the condition of the parts when they arrive. So that's something, if you're the person who handles the parts, be knowledgeable of it. If you're the person who is ordering the parts and someone else is receiving them, share that knowledge with them so that they have the same expertise on whether those parts have been submerged or have previous water intrusion, because it makes a big difference in how we're going to service the customer and whether we get a satisfied customer or somebody who comes back to get the car fixed and doesn't ever want to see us again. So that's a big deal for us. I want to look a little bit about at airbag systems. We're not going to spend a lot of time today on the airbag systems, but I just want to tell you that these are multi-component systems with very, very specific diagnostics, very specific replacement requirements, and in most cases now we're seeing these integrated in with the seatbelt systems. So you'll have the explosion of the airbags themselves, the explosion of the seat belt tensioner itself. These are all things that are quite important that they operate the way they did prior to the loss when we give the vehicle back to the customer. So knowing how the systems are diagnosed, again, the pre and post scans are really important. Something as simple as, can I pull the seat belt and does the retractor work? That tells me whether it exploded or not. If I've got a deployed airbag, that seatbelt should still be locked. The other thing that we don't check enough is, suppose I have an older vehicle that doesn't have an airbag system in it. What do I do to check the seatbelts if I do have a front end loss? I can pull the seatbelt out and just hold it in my hand so I can see about 18 inches of the seatbelt itself. If the seatbelt goes straight up and down when I'm holding it, just dangling it with its own weight, that means the seatbelt's good. If I hold it and it's on an angle, so I get a little bit of a curve in it, looking more like a banana, that seatbelt has been stretched to the point where the fabric will not stretch again, and that can actually hurt the occupant. So we would want to change that seatbelt. So the parts of this system, again, after we do the pre and post scans, it includes the clock spring, which is the igniter. It's the source of the ignition to the igniter assembly. So it's a spring that winds and unwinds with the steering wheel, so that as I'm turning, I've got a constant connection, but it won't, there's no resistance in the connection. So that's a pretty important part. Then that goes into the igniter assembly itself, which is actually, if you look at the airbag, it's the back of the airbag. Actually, if you're looking at it, it would be the front. The airbag itself would be the back. But that ignition source goes into that igniter module. Then you have the balance of the assemblies. Things to watch for. Most of these are going to be one-time only fasteners. So we've got to make sure that we're identifying if it's a one-time only fastener. Sometimes we can only use the parts once. With Nissan, they had several cars. They've changed it now, but up through 2015, things like the interior, the A and B pillar interior components that snapped on, all it is a covering, they were one-time use parts. And so it was very specific when we did our estimating processes that it identified it as a one-time only part. And what would happen is, if you tried to fit that part up again, it would feel kind of loose. It's really important that it's tight. The reason being, it directs how the airbag comes out. So if it's loose, and it doesn't, it's in less than a millimeter. These are fractions of millimeters that these parts are moving. It will change the deployment characteristics, so it's really important. And we need to check and make sure that if they are one-time only fasteners, that we replace them. There's another piece called a knee bolster that's underneath the dashboard, and it would be directly to the sides and underneath the steering column. We've got to make sure that if we have a deployment, if you have the weight of the occupant going forward, their knees can hit that. It's got a plastic cover. Just make sure that we check that to make sure that that part itself doesn't need to be replaced. If it's been bent at all, and you know, one of the questions you can ask the customer, were you the one that was driving the car? And if they were, did your knees hit anything? Can you remember that? Most of the time when somebody has an airbag deployed in their face, they don't really remember a whole lot, but they will remember if they have residual pain in their knees. And so if you ask the question, I know that I've used that questioning process before, and I found a lot about what in the interior has to get changed for that reason. If you have somebody that's of significant weight that hits the airbag system, there's also a collapse capsule that is in the steering column that gives, by manufacturer, they give very specific measurements for. It's wise to go in and just check the distance and make sure that the distance in that crush cap is where it's supposed to be, because if not, then the steering column itself has to be replaced. So these are pretty important things in that whole integrated airbag system. Okay, we talked a little bit about seat belts earlier, but there's some additional things with seat belts, because obviously we have an explosive retractor component to these. So what are some of the things you need to consider in writing the repair plan? Number one, obviously we're going to test. You're going to go in, pull the belt, make sure that it retracts. If it does, then it's fine, but it's going to be validated through our scanning. The scanning will tell you if there's been a deployment in that system. So again, the scan testing is extremely important. But that's the first thing. Number two, we're going to, again, look at that belt, hang it down, let it loose. If there's 18 inches If it's straight, you're good. If it goes down and you see a bow, you've got an issue with that part, and that means that the fabric has tensed up. It's made in a herringbone tweed for a reason. It's to move the strength from one side of the belt to the other. If one side of the belt is stretched, it will cause it to have that bow in it. So it's important to check to make sure that you don't see that. If you do, the belt has to be replaced. Then in addition to that, with the seat belts now, you also have a seat bolster that can be an explosive bolster. And again, that's for side impacts. But it's another area that we've got to look at. And why do I have to look at this? It may seem like it's insignificant, but if there's a tear in that bolster, even if it's from age, the bag will not deploy properly. If you have that tear, what it does is it allows the bag to move out faster. And even though we're talking about 1/25th of a second, we're talking milliseconds here where this moves, it can change the direction of how that bag deploys. So the inspection process on these parts is extremely important, and I don't think I can emphasize that enough. What are the things you're going to need? You're going to need a really good flashlight, very high CRE, a bright bulb, and you're going to look at all the seams. You're going to look at the retractor parts. All of those things are really important. One thing I do want to cover that I don't think is covered enough when folks do estimator, repair planner training is, what happens if the car goes underwater? So what are some of the things that you might want to look for? And what you want to look for, especially remember that this part for these seatbelt retractors is going to be at the lowest part. That D-ring mounting area is at the lowest part of the vehicle. So it's going to be right in the B-pillar rocker area. So water comes up to the bottom of the door, it's already above where this retractor sits. So it's worth taking off the molding, looking down inside with a flashlight and seeing if there's been any moisture down in that area. Again, the self-diagnostics for the system should tell you if there's going to be any issues, but there's nothing wrong with just doing a visual inspection and checking. Again, peace of mind, reduction of liability for the store, those are all things that are really important to the store owner. So we want to make sure we're looking at the things that protect the business. So that's important for us to look at. Now, as we get into mechanical systems, this is where it's typically the least amount of damage that we see on the vehicle in parts number, but significant in parts price. And so the diagnostics for this are really important because most errors that are made or supplements that we see or the highest frequency of supplements typically is in mechanical parts, but most specifically in steering components. So again, we've got to make sure that we're doing the quick checks that we can look at, and we're going to talk about those in detail as you go through the program, but let's just talk about some of the things that are involved in steering and suspension systems. Obviously, with your unibody car, you will have what's called a McPherson strut or a strut suspension. Struts typically now are front and rear. You may see some systems where you've got struts front, shocks back, but typically we're seeing them now with struts all the way around. So what's important? We've got to look at the strut tube. We've got to make sure that the springs are able to do their rise and fall with the suspension. We've got to make sure that all the mounting locations are where they're supposed to be, because if they're not, typically a part will bend when those parts move. So we've got to do the visual inspections. This illustration is of a front end system for a rear wheel drive car. And the difference being, if we look at the front wheel drive car, we have a rack and pinion steering system. That is quite a bit different than what you would see on the rear wheel drive car, where we have what's called a parallelogram steering system. The difference being we've got a big, heavy steering box that goes on the rear-wheel drive type vehicle. And this is traditionally what you see on trucks, like even light trucks. It's a smaller box, but it's still a significant weight to it, versus the rack and pinion system, which is lightweight. And it's an aluminum tube, basically, with a steel rod that runs through it, and it's a worm gear that operates it. So that is the difference between the two. In addition to the rear-wheel drive car, instead of having a strut suspension, we'll have a shock with an upper and lower control arm. So we have a little bit of different things that we look at here, and we'll talk about that more in detail, because the measurements that we used, kingpin inclination, and those things are a little bit different than we would have on from rear wheel to front wheel drive, and we'll talk about those in detail. But the standard things that you would look at, like toe, caster, camber, those change in the degree of measurements that we'd use, but they're the same measurements we use from one system to the other. In the steering and suspension systems, this is a really good diagram that shows this particular SUV that's pictured is a 4-strut system. And in addition to that, this one is front and rear wheel drive. So this gives you an indication of what a 4-wheel drive system would look like that is a strut system. So again, as we're looking and doing diagnostics, you're going to see a range of vehicles. Unless you're at a dealership that does one particular brand or multiple brands, you're going to be working with a lot of different kinds of systems. So it's really important for you to look at the VIN number, identify what's required for that particular car. Obviously, as you get more skilled in this, you'll be able to identify these things just on site. But some of the things that we have here, we've got to know struts and what struts do, what we need to do if they're repairable. Can we just repair the strut tube? All those kinds of things. Brakes, rotors, calipers, they aren't so much in the suspension system, but they are integrated into it. Obviously, we've got to stop the car. The CV joint, which stands for constant velocity joint, these are the front drive shafts. You can also have CV joints on the rear of the vehicle as well. But again, these are basically drive shafts. The next thing that we look at is the control arms. Typically in a strut suspension, you'll have a lower control arm. The upper pivot point, it will be on the strut itself. And then you may have some systems where you have a short arm, long arm, which means you've got two control arms. So again, the diagnostics for those are going to be a little bit different. What's important here is there's lots of moving parts that can wear out. So when you're doing your estimating processes and preparing your repair plan, the things you want to look out for are excessive tire wear. Let's say somebody just had an accident and the car had to be towed to you, but I see cupping conditions on the tires. That will tell you that that car had a pre-existing problem before the loss. That's something you have to document, because you're going to be fixing something that wasn't part of the accident. It was actually a maintenance issue. In reality, the customer owes for maintenance issues, separate from the impact issues. So that's something that you're going to want to share. Again, you're going to be bringing the information to the customer. If you're in a DRP program, or if it's an insurer pay, they're going to want to know those things so they know how to treat it as far as the claim goes that they're going to be working. But it's something we have to identify. Why? We don't want to put the car all back together and actually build in a problem that was a pre-existing issue. So we want to be able to do the proper diagnostics, looking, again, visual inspection of things like the tires, looking at, what's the movement of the ball joint? Is it difficult to move? Is it easy to move? Is there stress in it? Is there not stress in it? Looking at the urethane bushings. Have they been squashed? Do we see where they're cracked? That tells me that there's other issues that we may have to look at. So again, a really good flashlight, opening up your documentation from the OEM, what should it look like, and then take the flashlight, what do I have now? Let's go through some general mechanical parts. And again, we're not going to spend a lot of time on this today, but we will in the future. But the drivetrain that you're seeing here is a typical four-wheel drive drivetrain. What that means is I've got a transverse mounted engine in this particular illustration that shows that it is a front-wheel drive car. However, it does have a drive shaft that goes back to the rear of the car. So again, I can see constant velocity joints both front and rear, and this is illustrated so that you can read what those are. But it helps us to identify what some of those parts should look like. And then if we have an accident scenario, gives us a visual reference so that we can identify when there maybe is some problem with those parts. So there's going to be many different drivetrain variations depending on a lot of different things. Size, weight, performance packages. I may have a particular car where, and this is going to be really important to you, if you're working on performance cars, has anybody updated things like any sway bars, the bushing types that they're using? You got to have those conversations with the customer. If you see a car that has custom wheels, maybe some lower profile tires, I would ask the question about, have you done any kind of suspension enhancements on the vehicle, so that as you're doing your repair plan, you can factor those into the cost of doing the repair, because some of the procedures that are used in installing those aftermarket parts may be different than what you would use in installing the OE. So knowing the package that you're working with will be very helpful. Other things that are going to be really important here are how you bleed the brakes. What is the process that has to be followed, especially if you do work with anti-lock brake systems? Very specific bleeding processes have to be used. Depending on the vehicle, if you get into the cooling systems, if you don't bleed the cooling system in a very specific way, you can lock it up and create excessive heat in the engine, and we can burn an engine up. So again, I need to know when that system has to get bled, and the only way I know that is by following the manufacturer specifications. So these are all real important things that kind of validate where we said earlier that we want to talk about getting the OE specifications and identifying what specifically has to be done for that system that we're working on in that particular vehicle. These are really important in making sure that we put the vehicle back to pre-loss condition. Again, in these general mechanical parts issues, there's three pictures that you see in front of you now. These are some of the different types of motors that you're going to be seeing. We just did a presentation at an industry show, and we were looking at what is the difference between what we're seeing currently and what we would see in 2020, then from 2020 to 2025. Now, why does that make a difference? Well, we're seeing actually smaller engines that will be able to create the same amount of horsepower that we have in it, and I'll just use this as the illustration. The typical 2.5 liter four-cylinder motor that we have now, we're going to see that be reduced to, in the same configuration of vehicle, reduced to a 1 liter to a 1.5 liter turbo or supercharged motor that will produce the same horsepower. Why does that make a difference? Remember, I said early on that we're trying to make the greenhouse bigger for passengers, and we're reducing the size of the front and the rear spaces in the car. This allows that to happen. We can put a smaller power plant in. By doing so, we can improve, let's just call it the foot area in the passenger compartment. We can move that further out, so I can either get bigger people or move that seat forward and give more room to the back of the car. So that's one of the, and again, fuel economy, going back to the CAFE standards, these are all new innovations that we're going to be seeing. And that we're saying new. The turbocharged models are new. We've seen this engine from Daihatsu for about 6 years now. So it's not really a new motor, but you're going to have different configurations from General Motors, BMW, Nissan. They're all going to these types of systems with a much smaller engine. Again, same horsepower, but we're going to have the added diagnostic processes for these that they may be supercharged. And if they're turbocharged, it requires an intercooler. So we're going to have tubes that we may not see on a traditional vehicle. The thing that's important for you here is, and this is one of the things that as we talk with the insurers, they're not clear on this, and we're trying to get it crystal clear for them. This may require us to actually do motor teardowns in order to be able to see the structural components in the vehicle. The engine box is getting so small, that area is so compact, that we have to remove engine shields, we may have to remove peripheral parts that bolt to the motor just so we can see things like the frame rails, because they're all covered. So that would be a not included operation. Removal for inspection, not included operation. We need to add that to our repair plan. So these are other considerations that we need to look at as we're seeing these changes in not only the structure but the mechanicals in the vehicle that we will need to consider in our estimating processes. The cooling systems, again, another mechanical part. Typically what we see are three types of things that would be involved in the cooling system, and this is outside of the fan processes that draw the air through them. But obviously you've got a radiator, and the thing that I want to bring up to you here is there's all different kinds of radiators. You could get aftermarket, there's OE, there's used parts. Some things that you need to consider. If someone wants you to use a used part, the first thing you got to do, it needs a pressure test, and it's got to be thoroughly cleaned. And by thoroughly cleaning, it means that you've got to use a zinc process. It's a flush. You got to make sure that that system is cleaned out really good. If it's not, how are you going to guarantee its performance? You got to pressure test it. So all of those things that I just described are not included operations. So those have to be added to the cost of that radiator. So now I've got a group of things that build the cost of the radiator. And in some cases, it makes it not cost efficient to use that used part. But we just assume that because we're getting a used part, it's a good deal, but we forget about those not included operations that we have to add to it. So again, that's really important. Condensers. This is a real sticky subject, because if someone has, I'll give you for instance, if an air conditioner compressor clutch disintegrates, and now the shaft goes back in and goes into pieces inside that system, I've now contaminated that system. So one of the things I have to do is I've got to totally flush that whole air conditioning system in order to make sure that I don't have those little shards of aluminum inside the system. If I don't do that, and there's also some little filters that have to be replaced, etc. If I don't do that, what happens is you go ahead, you put it all back together, everything seems great. A couple months later, a customer comes in and says, hey, my air conditioner locked up. And the cause of that is we didn't take all the contamination out of the system. So we've got to make sure if we have any kinds of situations where that could be the case, we want to make sure that we're flushing, we're cleaning the system out. It's called a nitrogen flush, where we're blowing everything out of the system. Then we make sure that all the filters are replaced and all those processes are done. Each manufacturer has very specific processes that have to be followed, but these are typically mechanical processes. So in the collision world, we don't think about all those things that are going to have to be done. So it's important for us, again, looking up in ALLDATA or the OEM specs. It allows us to identify all the things that we really need to do, and so that's really important. The other thing that we would look at is, in the turbocharged cars, you're going to have this intercooler system. And again, you can see from this image, lots of piping. There's going to be lots of connectors. So remember, vehicle hits, comes back, all those things have moved. I've got to check all the clamps, I've got to check all the hoses, got to check all the tubes, piping. All those things have to be visually inspected. Then when the repair is finished and I go through the scan process, I want to turn that vehicle on and I want to inspect it while the vehicle is warm and under load. And rev the motor a few times, let the turbo kick in, and then check and see if I've got leaks. Those are things that if we look at road testing the vehicle is something we can charge for. Road testing a vehicle where you've changed mechanical parts, it's a must. Because unless you do that, how do you know? You don't want to just give the car back to the customer takes the car out, has some kind of a failure mechanically, and it was something that you could have easily seen in a road test. That doesn't look good for the quality of repair that the shop has done. So then they're going to question everything. So again, the road test is a pretty important part of doing any of these mechanical operations that we've been talking about. Now, we talked a little bit before in mechanical parts, we looked at steering racks. Here's a pretty good visual of a steering rack. And this one, there's different types. You can have an electric pump that's basically an assist. You can have a regular power pump that'll run fluids. There's a lot of different ones that you can see, but obviously if you have a damage in these areas, you want to make sure that you're looking for things as we have listed here, distortions in the rack itself. You want to be able to turn this rack and not feel any drag whatsoever. If you're feeling drag as you're turning that steering wheel, there's something wrong in the system. It should be a very easy motion side to side. So then the first thing you do is go do your visual inspection. I'm going to look at the seals. Do I have any leaks? I'm looking for cracks. All those things are really important. Now I'll bring up again the used parts. If for some reason someone is asking you to use a used part, some of the things that I would ask to make sure that I can, with assurance, tell the customer that it's a good part, has there been a dye test done on the aluminum part to make sure that there are no microscopic cracks? This is called magnafluxing. There's a lot of different things they call it, but basically you're spraying a dye onto the aluminum part, then you're spraying an activator, and once that activator hits, anywhere you've got a crack, you'll actually see a purple line. That tells you that that part has some issues, and I wouldn't want to use the part. So again, it's something that you may not do that test yourself, but I would make sure the people that you're buying the part from have done that test, and they can tell you that that's a quality part and that it's had a dye penetrant test done to it, just to make sure that it's in fact good, and you're not going to end up with some problems from it later on. Those cracks under pressure can open up and create some issues with drivability. Okay, so now we're ready for skill check number 2. So question 1, the following are types of lighting found in today's automobile: LED, HID, composite, or all of the above. Question 2, airbag systems contain an airbag and an igniter. True or false? Question 3, explosive seatbelt tensioners ignite when airbags ignite. True or false? Question 4, front-wheel drive steering systems are typically different from rear-wheel drive steering systems. True or false? Question 5, struts, CV joints, and lower control arms are all part of a front-wheel drive suspension system. True or false? Question 6, the following are all parts of the vehicle's cooling systems except the radiator, the intercooler, the condenser, the washer solvent reservoir. The next topic we're going to look at is electronics, and this is, and has been for the last several years, kind of the hot topic for collision repair, because it's something that we've had to deal with it, but we've always sublet it. And now what we're trying to do is, why are we subletting something from the collision repair facility that could be done in-house? So with that being said, we need to know first what needs to be diagnosed, or what diagnostics have to take place. How do they need to take place? Where do we do them at on the vehicle? What are the things that will be required to do? So in this, we look at, the first part that we look at is the ECU, or the electronic control unit. Essentially, this is the brain of the vehicle. It's the master computer that links all of the sensors, which can be smaller computers as well, but it links all the sensors, all the activities of the car to one central brain, so that that can tell everything if it's operating right, and if it's not, do I send a code, or do I just pull a history code? Does it show in the 7-second burn on the dashboard? Is it something that we have to go beyond? That's what the control unit does. It operates all those things. The drivability of the vehicle depends on the control unit being right, the performance, and the safety system. So it's a pretty important component in the car. I check it through the diagnostic link from 95 through current. We have the OBD2 style connector that you would connect the scanner into, and basically that would read the diagnostics for the vehicle. And as vehicles move into the 2020 model year, this has gone from being a non-essential task to an essential task, as we described earlier, that we go through all these scanning processes. The visual that you have now is, there are so many diagnostic tools out there, and what I tell folks as they're looking at these tools is, you get the one that fits your store. What is the cost of it? What does it cost to update? How does it link into, if you're using an off-site system that it links into, how does that work? Do you have the capabilities for your internal systems, internal mechanisms to communicate properly? All those things are really important, but at the end of the day, what all of these things need to do is to do the diagnostics that will tell you if the system is functional, if it's not, what the issues are, identifying what parts are affected by whatever the codes are that you're seeing, and then be able to validate, once the systems are corrected, that number one, the system has been recalibrated, and number two, that the system is fully functional. The secondary need is the ability to print out the diagnostic processes that you've completed. Why is that important? Well, we have a lot of insurance companies that are questioning whether or not it's required to do these diagnostic processes. So essentially what you're doing is validating through the paperwork that you can print out of these systems that you did do it, when it was done, the VIN number of the vehicle that it was done on, all of those things that will validate when you ask for payment on that particular operation, that you in fact did it, so that they will pay the bill without any kind of issues. So again, this is crucial when dealing with third-party payers, such as the insurance company. One thing that I want to bring up, because it is becoming a real issue for us, is the photo estimating that's being done. What happens is an insurance company will get a photo estimate, or a photo of the vehicle, then they will create an estimate off of the pictures. Well, the pictures obviously don't do any diagnostics, so a significant amount of the damage is not being identified by the insurance company initially. So we could potentially have an unsafe vehicle being driven because they're using that process versus the car going to the shop and having the shop do detailed diagnostics with a scan tool that identify every issue that's contained within the vehicle. So this is really becoming a point of contention between the insurance companies and repair facilities. And the only one that's suffering from it right now is the consumer, who could potentially be driving a vehicle without safety system functionality because somebody just took a picture of the car and sent them an estimate. So when we talk about these systems, one of the things that the control unit reads are the sensors. So as you can see in the illustrations that we have, the red arrow is pointing to a wheel speed sensor. It's simply a magnet that is read by another magnet, and it's reading it's the wheel speed, and what it tries to do is look at if wheel speed tries to drastically change quickly, that is what would set off the anti-lock brake system. So it's a pretty important piece of the vehicle. The parking and perimeter sensors, those are the ones where you see the small indentations in the front and rear covers. I mean, there's a lot of different things those are used for. The blind spot mirror, that has a camera in it that reads within a certain amount of degrees and in a certain amount of feet on the side of the vehicle where another vehicle could potentially be located to keep the driver from making a lane change into another vehicle. So as we see these, there's lots of different sensors, and in one symposium I went to recently, Chrysler said that there was 150 sensor operations that the ALDL monitored when you plug the link in. That's a lot of systems that an insurance company will say, well, why do we need to check them all? Well, because number one, the manufacturer says so, and number two, there's no way I can visually inspect all 150 of those areas and know what they're doing. It takes a scan tool to tell us that. So it's really important that we understand in our conversations with the insurer that we've got to communicate to them what some of the issues or some of the locations that these sensors would be. And in this next illustration, which is one of the best ones I've seen, it shows all of the different areas that this control unit is going to scan and tell you the condition of each of those systems. I mean, we can night vision, driver alertness monitoring, and with that one, we're going to have to be cognizant of the fact that it's got two cameras, one that faces forward and then one that faces backward. And what it'll do, it's got retina detection. If it sees that the driver is falling asleep, it'll start braking the car and pull it over to the side of the road. If you have a driver who, God forbid, has a heart attack, it will monitor it through a watch type system like you would have for exercise. It will monitor that again. It'll do the braking and pull the vehicle over the side of the road. All of these things are systems that are going to be in 2020 vehicles, and we're going into 2018. So we're not far away from these. So we've got to be aware of these things as we're developing repair plans for these vehicles. It's really important, and I can't stress this enough, all the options that that vehicle contains must be properly identified when you begin the repair plan. When I go in and I'm starting to click on what are the options, I need to make sure that I go through and every option that that vehicle has is identified. If I don't do that, I run the risk of changing the procedures that will be put on the estimate, and I may be omitting not only things that we need to do to make the vehicle right, but I could be omitting systems that are in place that the customer bought, and we're not even addressing those in the repair of the vehicle. So again, we're looking at these recalibration processes to validate that the occupant safety systems are fully functional again. This is non-negotiable. This isn't something that someone can tell me that, oh, you don't have to do that. No, this is a non-negotiable. I have to do this because I've got to make sure my customer is put back into the condition they were prior to the loss. So this second illustration, and this one is, it may look familiar to you from CCC, but it goes through some of the other things that are more of the convenience package items. We went from safety systems, now we're going into convenience packages. So there are a lot of different things that, again, these can trigger fault codes. I can't see them as a repair planner. You're not going to know it until you go through those scan code diagnostics. So again, it's non-negotiable. We've got to make sure that things are done in accordance with what the OE wants to have completed. Next, we're going to talk about glass. And now, glass is kind of an odd topic because we never consider glass as being part of the structure of the vehicle, and it is. It's a significant part of the structure of the vehicle. So much so that the rollover characteristics of the vehicle under FMVSS 2020, or I'm sorry, 220. FMVSS 220 is the federal rollover standard for passenger cars. What that means is, as the vehicle rolls over onto the roof panel, it has to take X amount of crush, and the glass is an integral part of the crush characteristics of the roof. Crazy as it may sound, it's an integral part of that system. So, two things are really important here. Number one is the glass that we're using in the vehicle has to be of the specification of the OEM for that federally required test when the car was built. Second thing is the adhesives that are used to hold that glass in place have to also be calculated in that structural, it is a structural adhesive. So it has to be calculated into that structural crush, and again, that's FMVSS 220. It will say that it is compliant right on the label for the materials. The other things that are important here are how are we putting the glass in, who's putting the glass in, how long has it cured, so how long has that material cured before the vehicle goes out into the weather, because it says very specifically 24 hours at an ambient temperature of 72 degrees, and it gives a parameter of the temperature. So we may need to look at in the future, is there stall tie-up time that should be charged into the estimate as well while the urethane cures. So, and again, that's not something for today's topic, but that is something that we're going to be looking at in the future. So, in an effort to cycle the vehicle quickly through the repair process, we've got people that are coming out with all of these quick cure adhesives. We need to know that that adhesive will withstand the requirements of FMVSS 220. If it doesn't, they shouldn't be using it. Another thing that needs to be looked at here, let's say you're replacing a quarter panel, and where the quarter panel joins the B pillar and the C pillar at the sail panel, you've got an area that has been cleaned off in order for the weld processes to take place. The adhesive, or the area where that adhesive is going to be placed once the vehicle is painted, that needs to be taped off so that you have bare metal there, so that when the urethane primer is put on, it is going on bare metal. That is a requirement of most of the adhesive manufacturers. You cannot put the urethane over fresh paint. If the urethane goes over fresh paint and then you put the glass in place, if that car rolls over, that glass is going to pop right out of the car, because it will actually adhere to the paint and it will pull the paint right off of the car. That's how strong this adhesive is. So again, just kind of keeping an eye on how things go, and I don't know how many of you will have a responsibility of looking at the production processes in the store, but that is another thing that we like to look at, just kind of a checks and balances to make sure that the glass is being installed correctly. So next we'll go to skill check number 3. Question 1. The following sensors report activity back to the ECU. The airbag systems, the air-fuel mixtures, the anti-lock brake systems, or all of the above. Question 2. All passenger cars manufactured contain a diagnostic link connector. True or false? Question 3. Pre- and post-scanning are not required by OEMs after a collision loss. True or false? Question 4. It is necessary to calibrate any system where a sensor has been replaced during repairs. True or false? Question 5. Specific types of urethane adhesives are required for glass installation. True or false? And number 6, examples of sensors equipped on vehicles with appropriate options are wheel speed sensors, parking and perimeter sensors, blind spot sensors, or all of the above. Okay, as you can see, we're going to cover some general information, but as you can see, the repair planning process is a pretty meticulous process that involves looking at a lot of different things other than just what's that dent and how much is that dent worth. So we need to look at identifying damage completely is a time-consuming process. What that means is we have to do the meticulous disassembly. We have to go step by step in looking at a component part, breaking it down into individual parts, and identifying where all of the damage has occurred in the vehicle. So because of the damages, if we look at the damage the same way each time, a systematic approach to the damage analysis, what we find is we reduce supplement frequency, we reduce the add orders or the additional part orders that we have to make, which cause the repair to take longer, so we can reduce the time. Therefore, we gain efficiency, which means I can get another car through the box, which if you're the repair planner who's getting paid a bonus, means guess what? Your bonus goes up. So all of these things are part of that process. Now, there is always a caveat to this. And for the folks that are doing estimates/repair plans for DRP programs, things are going to be a little bit different than for those who can work independently of the insurance company. So there may be some things that are agreed to just as part and parcel of being in that program. And you know what? It's a business decision that's made, and you live with that business decision. However, when it comes to things that are mandatory for the car to be repaired properly, those things should show up in that repair plan, even if you have to put a no charge because that's the agreement that you've got with that DRP program. You still should have that listed for liability reasons. You need for people to understand, well, we didn't get paid for it, but we did it. And here's the result on paper that we did do the inspection. We did go through these steps. However, because of our agreement with the insurance company, we're not charging them for it, but at least the customer knows it was done. So that's really important that we look at that. Whenever possible, we always look at this 7-second burn in the dash pod, but that really limits us to only about 7 systems, safety systems that we look at. So again, I want to kind of reiterate this, and we're going to talk about this as we go through the virtual class. We go through CEST1, which is the Estimator Basics 1, and CES2, which is Estimator and Sales Training 2. All of these classes, we're going to continually talk about looking at the scan processes because they are absolutely mandatory. That 7-second burn, again, looks at certain systems, but when I look at the scan process, it looks at the entirety of the system. It looks at the control unit and what has the control unit found wrong with all the systems within the vehicle. I want to look at the topic of direct and indirect damage again. When we look at direct damage, remember I got my brick wall, car hits the brick wall. The area of the front of the vehicle, that is the direct damage. I know we covered that already, but I want to just make sure this one has to be in stone. That's direct damage. When I get deflection, anything that moves back, or as the vehicle is crushing, all the damage that occurs away from that direct area, that's called indirect damage. The interesting thing about this, and we need to think about this in our repair planning processes, it's the last damage in that's the first damage that has to come out for me to reconstruct the vehicle properly. Okay? Last in, which means that indirect damage away from the area of direct impact, that's going to have to come out first in order for me to reestablish the length, width, height of the vehicle, the 3 dimensions that we've got to restore. So we're going to cover that in detail in other programs, but just so that you have a clear understanding of what we're looking at with that. So the objective of us doing this meticulous disassembly process, we want to expose all damage by removing one part or component at a time, examining it, removing all the attached parts. That includes things like wire loom fasteners, and in the case of the rear body panel, which we talked about earlier, a lot of those come with a welded on wire loom holder from the factory that does not come on the replacement part that you would order as a crash part. So we need to keep in mind that the removal and reinstallation of that loom, which requires a spot weld, there's 2 of them, and it requires a spot weld on each one of those are not included operations. So the removal part of it and then the reinstallation, we need to add that to the estimate. So as we look at this, the goal here is to reduce the need for supplements. Right now, as you get an estimate from an insurance company, 100% of those are going to require a supplement. And the problem that we have is typically we're seeing, well, I should say, pre-photo estimating, we used to see about a 4-day average in the length of time it took to get a supplement looked at, paid for, etc. Right now, that has jumped to between 8 and 12 days. So we're having a severe problem with lag time because, let's face it, the insurance companies have let go a lot of their claim staff that was handling those things. So now we're kind of at the mercy of when can they get here. So it's really more advantageous for us to get the vehicle in, do a thorough and complete disassembly of the vehicle, have an itemized list, and create the environment where the insurance companies are used to our shop being the one who gives them a thorough and complete estimate with relatively few, looking at about 8% or less supplements. That will get them to say, okay, we trust those folks. And it will get the estimating to a point where even in the circumstances we're running into now, you will have less friction, if you will, in trying to get supplements paid for. So again, a thorough and complete assessment of the damage, an accurate repair plan gets you to the point where you get the credibility and buy-in from the insurance company that reduces the amount of times that they're going to come in and check your work. So that's really the goal here, is how do we get our system more efficient so that we're not at the mercy of those 12 days like other shops are. So as we go through this, we're going to look at not included operations. So you've probably heard in the past, I will reiterate this, and I'm going to tell you, I still use them at least a couple times a week. I refer to the P pages. And those preparatory pages that we have, these are procedural pages from the estimating system providers that we use. There's also from SCRS, the Society of Collision Repair Specialists, CIC, which is the Collision Industry Conference, and ASA, the Automotive Service Association. They also have not included operations that you can go into any one of their websites and pull those down as well. But this is all reinforcing documentation that will get you paid for items that the insurance companies typically don't recognize because they don't have the paperwork to validate it. These websites can actually give you, not only the websites, but the P pages will give you that documentation. For those of you who use the mechanizing estimating systems, most of those have internally, those documents are internally built into the system. So we just want to use those as a reference so that we're making sure we're getting paid for what's owed to us. One of the things that you have with welded panels that's important to know is if you are going to weld a panel in place, you're supposed to do a test weld. So you're supposed to do 2 tabs of the same material that you're going to be welding into the vehicle. You do a test weld and you do a destructive test to make sure that the weld nugget pulls away from the part that was welded, or the 2 parts that were welded together. That is also something that is actually required whenever you weld. It's a not included operation. That can also be added to the estimate. Typically that's about an hour. You get some money for cutting the coupon material out, and that whole process is something you can get paid for. It's validated in your P pages, and it's validated by those 3 associations I named. So again, it's a way to continue to enhance your estimating. So what do you do if the insurance company says, we don't pay for that? That's not something we consider. Or, hey, you know what? You're the only one that charges for that. We're not going to pay for it. The position should simply be this. If it's required, and I have manufacturer documentation, I don't care if Joe's down the street charges for it or not, I'm charging for it because it's required to fix the car properly. Now, if somebody else doesn't charge you for it and you're not seeing on their estimate, I am not going to be one of those guys who is not going to charge what's necessary to put the customer back to pre-loss condition. We have to do that. It's not only a business obligation, it's a moral obligation that we put the car back to the way it was before that customer had the loss. So those conversations do get sticky, and again, I would advise you to go into the portal. You can go under the teleseminars. There are 2 negotiation pieces in there that will help you in preparing for those kinds of discussions. But the issues about the conversations and the negotiation tactics, those things need to be followed through with. And if you've got multiple estimators or repair planners in your facility, they need to calibrate. You want everybody on the same page with every issue. If one's going to charge X amount for corrosion protection, the other's got to charge the same amount. So that you've got kind of a standardized process so that when the insurance company comes in, they're not going to the one who charged them the cheapest amount last time and saying, you know, they set precedent here. No, we say that this is our process for charging for a particular operation. This is how much it's going to be. We're going to be consistent and repeatable in that. And then the third part of that is always having the discipline to continue that moving forward. So it's consistent, repeatable processes, and the discipline necessary to continue to move those forward. Negotiation tactics they're really not as difficult as people think. If you have the documentation, typically the one with the most data wins. The pricing, I don't care about the pricing, I care about the data. The data will dictate what the pricing should be. And then again, the consistent, repeatable processing will allow you to consistently get paid for it. So let's look at the damageability. As we go through this now, we know we've got to disassemble parts so that we can identify, even again with the smaller engines, we're crowding the engine box, we need to remove things. We know those things are going to happen. We know that the area of direct damage obviously is going to be where the most damage is going to occur, but the damage as it goes further away is the first damage we have to consider in moving it out, because what we're seeing as that damage goes out, it's dissipating, the energy is dissipating. But if I'm seeing damage further back into the vehicle, it means that the damage has in fact transferred. Even though it's dissipated, something has happened to move that damage all the way through the vehicle. So again, let's go over real quick direct damage, the illustration here to the left rear cover of this Honda. It says very simply, direct damage or the area of direct impact is identified as the area of direct damage. Typically this includes outer body panels, lamps, exterior bolt-on components, and in this example we have the rear cover, the bumper, and the rear body panel are impacted here. Now what's interesting about this is if in fact this were a photo estimate from an insurance company, the only things that you would see estimated here would be the rear cover. Why? Because they cannot see the rear body panel and they cannot see the bumper. So you'd have probably about a $400 or $450 estimate, and we know that this damage is probably going to translate into $2,300 to $2,700 without any issues, and that depends how far the damage transferred in the vehicle. So this is an important point for us to remember. The indirect damage on this, and this is the same car, now I'm showing the right side of the vehicle. Now, remember the first picture we're looking at is the left rear. But it's hit hard enough so that the damage transferred into the right quarter panel and caused an oil can right below the sail panel. That is indirect damage, damage away from the area of direct impact, but it is part of this loss. So I have to go in and say, okay, now I've got to correct the damage to that quarter panel, move it around with whatever means necessary. I've got to measure to tell me how much time. All those things have to get done so that I can identify what has to get done. And this is damage caused by deflection. Very simply, the damage pushed through the vehicle until it came to a point where it was going to stop. It had no place to stop, so it tries to go through that outer panel, causing the oil can that you're seeing there. Then we look at gap and flush, and this is one that's really important. These are body alignment visual indicators. We're going to look at, there's a space that you will have, typically it's about 3 millimeters, about 1/8 of an inch, that we see between the panels. I know you used to see commercials where you could roll a marble down and the marble would very effortlessly go down the panel. And if the panel was wider, you would see the marble slow down. That's how we look at this. We want that panel to be very even all the way through. If there's a difference in those gaps, it means that we've had structural misalignment. So if I have the front of the car here, I've got the rear of the car here, the rear of the car deflects upward and stays, that's going to give me wide gaps on the bottom, narrow gaps on the top. That's going to tell me that I've got deflection. Very simple way to look at this. We'll go into this training in much further detail in later segments. This next illustration is an important one. So we're looking at this neon, and what I wanted to show you in this illustration is the gap and flush that you would check if I have a front end impact, as is illustrated in the second illustration. I want to check all of those gaps to see where, if there was deflection in the vehicle, what actually happened. On the left side of the vehicle is where the impact occurred. Typically what's going to happen, if again this would be the front of the vehicle, this would be the back, if the damage is on the left front, I'm typically going to see the back deflect and try and move forward towards that area of damage. So I would be looking for closed gaps on the left side of the vehicle and wider gaps on the right side of the vehicle. That would mean that I've got that the center of the vehicle has remained in place, but the left front has moved over and the right or the left rear has moved over, causing kind of a banana look to the structure. And so those are things that are going to tell me this is going to be a more complex pulling operation, so I need to start thinking about what do I have to do to reverse that damage when it goes on the frame machine. So as I look at the second and third images here of this neon, this is so that you can visualize how that, and we call it a crash pulse. The energy that moves out into the vehicle is a pulse that comes from that sudden stop that we would have at the direct impact. So what I'm looking at is where did it transfer to, and these illustrations give you an idea of how that will occur. The thick red arrow is showing you that you got to remember that the back of the car, once the front stops, the back of the car is going to try and catch up to the front until the energy dissipates enough so that the vehicle stops moving. And that's going to happen 100% of the time. That crash pulse is going to occur. 100% of the time, the area away from the impact will try and get to the area of the direct impact. And so we'll cover that more as we go through the program. But the next illustration that I'm showing you here is looking at an SUV, and this is a great illustration to show how the crash pulse occurs and what you have to look for. In this illustration, it's showing the vehicle gets impacted in the front, and I've got equal distribution of the damage to both frame rails. What it's telling me is as that occurs, the damage is going to go back, but there's a kick-up area in the frame rails which is going to push the damage down and under the driver. There's also frame rails above that are going to push the damage up and over the driver. The idea is that greenhouse that we talked about stays safe and the damage transfers around them. As that occurs, remember the damage is going to dissipate. Things that I have to look for on a substantial impact, I've got to look for, did it crack the windshield? If it cracked the windshield, that means that the roof section, as the damage was coming back and it's moving forward, there was enough stress put into that windshield that it cracks it. Very common occurrence. The other thing that we run into a lot that we typically miss and have to supplement, remember the engine moves and I've got the structure moving. Transverse mounted 4-cylinder engine with the exhaust in the back, where do they put the O2 sensor? Within about an inch of the firewall, or the cowl panel. So as that cowl panel moves and the engine moves back and forth, the next thing we know, the repair's all done, we go to turn the car on, we've got a code for the O2 sensor. That's why we do the pre-scan to see if that sensor was broken in the initial impact. So a lot of things, again, you can follow the arrows and see where the damage is transferred through. But on this particular one, it's gone through the core support, it's moved back. The core support, again, remember we said that's the tie bar in the front of the vehicle, and our rear body panel is kind of the tie bar in the back of the vehicle that holds the quarter panels in place. The core support is what holds the structure that the fenders bolt to in place. So we've seen the damage transfer through the vehicle, and again, the damage is going to try and continue to move forward until it dissipates back as indirect damage. Again, I just want to reiterate some of the things that you'll visually be able to see: oil canning or indents in the metal, overlapping of non-bolted to bolted parts, or even in a four-door situation, bolted over bolted parts. Look for crack seam sealer, any kind of seam separation. And the other thing is, and I know this is going to be hard to see, but if my knuckle is the weld joint and the weld joint moves forward, you'll actually see a dimple, an outward dimple, if you will, where the weld joint has pushed up. And that's pretty typical of what we see when we see the damage transfer like that through the vehicle. So again, we're going to cover a lot more of these things in greater detail, but it's really important to have a kind of a firm understanding, if you will, that the damage just doesn't stop in the area of direct damage. It's going to continue going till it loses its energy. And we got to remember, where it lost its energy is the first place you've got to check for damage, so that I can pull that damage back out in a way that will restore the structural integrity back to the vehicle. Now, we are going to talk in detail in future segments about what do I do to structural members, how can I heat them, what do I have to do to move them, what is the frame or the structural realignment processing. We're going to cover that in detail later on, but remember that we just need to be aware that these things do occur. Okay, let's go into skill check number 4. Trouble codes that show up in the 7-second burn when the ignition is cycled tell all the electronic and electrical issues on the collision damaged vehicle. True or false? Question 2. Estimating and repair planning, although used as universal terms, are different. True or false? Question 3. Supplements can be reduced or eliminated using the meticulous disassembly processes. True or false? Question 4. Damage stays confined to the area of direct impact. True or false? Question 5. It is important to use a systematic approach that is consistent and repeatable. True or false? Question 6. Damage can travel from the front to rear in frontal impacts and can be evidenced by gaps that are tight, gaps that are wide, parts that are overlapped, all of the above. To summarize the information that we've covered today, this workbook is intended to provide a general overview of nomenclature relative to the parts, procedures that are used in a typical collision repair. Repairing damaged vehicles is a very detailed process, and it involves many complex systems. I hope you gain that from just looking through the systems that we talked about today. The information contained in this workbook is only the first step in preparing for the many steps required to complete a detailed repair plan. Additional information will be provided as you complete the estimating and repair planning workshops as we move forward. The following are some of the additional activities that must be completed prior to the virtual estimating and repair planning workshop segments. And what these are set up to do is just have you go and look at some of these things that we talked about. So, number 1, we want you to observe a structural repair being performed. Then while you're observing that, have the technician point out the following parts: the lower frame rail, the upper frame rail on the front of the vehicle, the radiator support, the rear frame rails, and then the A, B, and C pillars. So we want you to take an actual look at these things so that you understand moving forward, here's where they are, and now I know what they look like. Number 2, we'd like you to observe the measuring process and the multi-step system in use. So what that means is the multi-step system is when the pre-pull measurements are being taken, when the during pull verification measurements are taken, and the third part, when the post-pull validation measurements are taken. So there's 3 steps. Each one will require a printout. We want you to observe all of those processes being done so that you can observe 3-dimensional measuring, what the technician does to set the car and the machine up, and then what the results are, and then the comparison of the results to the OEM specifications. Number 3, we want you to observe disassembly processes being performed. And then while observing them, want you to look at the following. Number 1, processes being used to remove the parts that are attached to the vehicle. Number 2, the process used to determine whether the parts are repairable or if they will require replacement. And then the actual use of the estimating system, picking out the guide numbers, making sure that all the options are identified, all those steps within the estimating process. We want you to observe that those systems being used. Then the fourth one, and this one I'm going to give you some cautions on. We want you to observe some welding processes being completed. However, I want you to make sure that you're protected. If you're right next to it, if you're going to wear a welding jacket, at least a leather, some type of leather coat to keep you from getting weld slag onto you, and make sure that you have the appropriate eyewear or a welding helmet so that you don't hurt your eyes. But I want you to actually be able to experience what that technician is doing to install the parts. So first, how are the existing parts prepared prior to the new part being installed? So what are we cutting away? Are we measuring a certain cut line? All those things, because those are the things you're going to have to determine time for in developing your repair plan. Second thing, the actual welding, bonding, or squeeze resistance welding processes. The reason why we put all three of those, some new vehicles may require you not to weld. They may require rivets and bonding. So if that's appropriate, we want you to observe that as well. But the welding would be a MIG welder, and then the squeeze resistance spot weld, that's the one where you'll have the transformer in the arms, etc. So whichever one of those you're observing, we want you to make sure that you're seeing how the parts are being installed. Then the next step would be, how are the repairs finished? What are they doing? What types of things are they using to finish the repair? And then the important one for you, because this is the one you'll have the most difficulty with the insurance company, is what are the steps taken to reinstall corrosion protection once the parts are replaced? Itemize those, identify the length of time, and then ask your manager, ask the owner about what dollars we're going to assign to the materials that are consumed within that process. So once this has been completed, you're ready to proceed to the virtual estimating and repair planning workshop segments. And that's all I have for you today, and I look forward to meeting with you on the other segments. Again, thank you for attending this pre-workshop. My name is Keith Manich. I am the training director here for our collision division. You can reach me at kmanich@autotraining.net. And if you have any further questions that you would like for us to answer for you, please address them to collision@autotraining.net, and we'd be more than happy to answer those for you.